The paper title is HyperDet3D, Learning a Scene-Conditioned 3D Object Detector. The task of indoor 3D object detection aims to locate and classify object of interests in complex indoor scenes. Previous methods tackles the problem by voting for the object individually, or explore the dense relations between object proposals. However, these methods are limited by their within-scene prior. For example, if we only look at the object proposal in this example, we are likely to recognize it as a cabinet if we only refer to the object-based prior or relation-based prior. However, conditioned on the prior knowledge that the object candidate lies in a kitchen-like scene, we may infer that it is more of a fridge. To this end, we propose the HyperDet3D network for this task. Compared to the traditional 3D detectors, our HyperDet3D enables the object representation with scene prior by adopting a scene-conditioned hypernetwork, which sets weights for the decoder layers in the target 3D detector. One type of scene-conditioned knowledge HyperDet3D learns is the scene-agnostic knowledge. Such knowledge is generally shared by various scenes, such as the dependencies between objects and scenes, so they are called scene-agnostic knowledge. To learn scene-agnostic knowledge, we randomly initialize feature embeddings consumed by the MLP-based hypernetworks. At training phase, the embeddings abstract all the training scenes and get updated during training iterations. Another type of scene-conditioned knowledge that HyperDet3D learns is the scene-specific knowledge. From the current input scene, we may infer what objects are more likely to exist. At test time, we use the current input as scene query from scene-agnostic knowledge, so that the general and shareable knowledge can instruct the object representation. Specifically, we randomly initialize another set of embedding features, and use the current input scene to query the embedding features. Such query mechanism is similar to deep SDF, which adapt the current surface point to a certain type of 3D shape. Our final scene-conditioned knowledge is the fusion of the scene-agnostic and scene-specific knowledge mentioned above. Our HyperDet3D contains a backbone encoder. We use .NET++ in our case, a series of object decoder layers each containing a transformer decoder, and object detection heads. We use the output of scene-conditioned HyperNet to replace the weights of FFN layer in decoder layers. One problem is that the output tensor of HyperNet is much smaller than the weight matrix in FFN layer. One simple solution is to repeat the tensor in all dimensions. To enhance the expressiveness of our scene-conditioned hypernetworks, we propose multi-head scene-conditioned attention by re-initializing the input embeddings multiple times. Compared to previous object-based and relation-based methods, our HyperDet3D achieves state-of-the-art performance on two widely used 3D object detection benchmarks, ScanNet and SunRGBD. Also, due to the usage of hypernetworks, our model is smaller than previous state-of-the-art while achieving better results. From the per-category results, we can see significant improvements on categories which is more dependent on the scene prior, such as bed, fridge, bathtub and so on. The exception is bookshelf, which we infer is due to the scarcity of the library scenes. We also conduct cross-dataset evaluation. We trained the model on the SunRGBD dataset and evaluated on the ScanNet dataset. HyperDet3D demonstrates better performances than representative object-based and relation-based methods, in terms of both 8 shared categories and 18 ScanNet categories. The qualitative results demonstrates that the scene prior knowledge helps to eliminate the ambiguity in 3D object detection. We did ablation study on the learned scene-conditioned knowledge and attention mechanism of MSA. It verifies both scene-agnostic and specific knowledge are crucial to our framework. Besides, the mechanism of MSA enhances the expressiveness of the object representation. Also, as our HyperDet3D does not use scene-type labels, we compare it with the baseline which conducts multitask learning including scene-type classification, which means this baseline incorporates the scene-type labels. It shows that HyperDet3D still achieves favorable results.